Please.
Start, please.
Good evening, everyone. Welcome to the Centenary Celebration of the Department of Mechanical Engineering, IIST Shibpur. Today, we are here for the 39th lecture series under the Centenary Lecture Series to be delivered by our honorable alumnus, Mr. Shubhendu Dasgupta, on the topic nuclear safety. The chairman, the session will be chaired by Professor Kamal Sharkar, who is the Associate Professor of Practice, University of Texas, Rio Grande Valley, USA. Over to you, sir.
Thank you, Joy. It is my great pleasure to introduce my great friend of almost 60 years, Shubhendu, rather Mr. Shubhendu Dasgupta. Shubhendu graduated in 1969 from B College with a degree in mechanical engineering. He later got his graduate degree in 1976. Shubhendu spent most of his life in design, construction, and starting up nuclear plants in various capacities. After his retirement in 2001, he was still active in upgrading various nuclear turbines for various companies all across the US. One of his focus areas was safety. He believes that safety starts from conception, redesign, construction, operation, and maintenance at minimum, and does not even end after retiring the plant. Safety is at every step of the way in his mind. In any case, this is his baby. This is his strength. He'll talk about it at length during the presentation. However, let me tell you a couple of other interesting strengths of my friend Shubhendu. He's an entrepreneur. He has a company right here in Kolkata called Supreme Mannings Induction Heating Private Limited. It is a small yet unique company with about 30 or so employees. Nevertheless, it is only one of a kind company in whole India specializing in the area of induction heating technology. He is one of the founder member and board member of this unique company. Last but not the least, Shubhendu is a world traveler. More importantly, unlike many travelers, he is a gifted photographer and narrator. Through his unique traveler, he always takes us to distant places like Ecuador to near-home places like Ladakh and Leh. Every time you feel like you yourself are also traveling with Shubhendu. What a talent. Thanks, Shubhendu. Back to business to nuclear safety. Shubhendu, the floor is yours.
Is my screen visible? Hello, am I audible?
Yes, screen is coming, but you can go for full screen mode.
Okay. Is it visible now?
Yeah, it's coming. Speaker may start, please.
Sir, please unmute yourself.
Shubhendu, please unmute yourself.
Yeah. Once again, he is muted.
Please press the unmute button.
Can you hear?
Please go to the WebEx screen.
Yes, I unmuted it.
Yes, now
Okay.
you are audible.
It's, yes, you are not audible. Shubhendu may proceed.
Yeah. Can you hear, right?
Yes.
Should I go ahead?
Yes, please.
Okay. So slide number 1 is just the introductory slide of the nuclear plant safety. So basically what we're going to talk about is the safety aspect of the nuclear plant, and it'll be interesting and as we go along. Let's go to slide number 2. Next slide. No, that's slide. Okay, slide number 2. That's good. This is a picture of a generic picture of a nuclear plant. There's a cooling tower and all these things. The reason that I choose that nuclear plant safety is nuclear power itself uh, plays a significant role in the total global energy mix. As an example, in the USA, we have a 93 operating reactor, which produces about 19% of the total power that's needed. So that's a fairly significant amount of the base loaded power. So it is important to talk about safety because we know what happened at TMI in 1979. After the TMI, basically the nuclear plant culture has been totally revamped, rewritten. The old culture was completely thrown away. And I was there when things were happening. Well, Pradeep was also there when things were happening, but we learned a lot and we realized that safety itself for the nuclear plant is probably a single most important thing. And if you follow safety to our heart, the design, the operation, and the maintenance, they all will fall in place and they're correctly. So, so that's why, just an example, after TMI, all these safety systems, and they were all upgraded and people's safety culture was enhanced. And right now right now is the capacity factor in the USA for the nuclear plant is a 94%, which is significantly higher than the average global factor of 83%. We run from one outage to the other outage without bringing the plant down. And that's all because of the people who design, operate, and run the plant and maintain the plant. They have internalized the safety aspect of the plant, and they have internalized the how to follow the technical aspect of it to its heart and make the plant safe. So, and that's what we're going to talk about. Okay, slide 3. Okay. Okay, slide 3 is the safety and the non-safety. It's just a breakdown. But every nuclear plant consists of 2 sets of systems and the components. There's a safety system and components and the non-safety systems and its components. generally there is a picture, I think it's on slide number 6, and we'll get to that picture a little later. But right now, the safety systems and structures and the component, the SSCs, they are everything up to and including second mainstream isolation valve. Typically, there are 4 mainstream lines coming out of the reactor, and they penetrate the primary containment and the secondary containment, and then they go inside the turbine building and the auxiliary building and all the other jazz. Now, they are all non-safety. But the safety is up to and including the second isolation valve, which there are 2 isolation valves on this each mainstream line. One is inside the secondary containment. The other one is just outside the secondary containment. So up to that valve, everything, including primary and secondary containment and their components, they're all safety related. The rules and the regulation, how to design, operate, maintain, and even to talk about those things, they are a lot different than non-safety, and we'll get to that. And then non-safety is the downstream of the MSW I just talked about, and we call them balance of plant, BOP. And everything up to the second isolation we call NSSS, which is nuclear steam supply system. So you'll hear these 2 terms, NSSS and BOP, as they go along. So the rules for the safety and non-safety is quite different, but at the end, the safety culture, they all join in one place and make this whole plant a safe place. So that was slide 3. And can you go to the slide 4? Okay, slide 4 is kind of misplaced, I guess. This is basically how many topics I have selected in the presentation. Safety, non-safety, we already talked about. NSSS safety approach, how do we go by and create this the safety culture of NSSS? And that's another slide we talk about. BOP is the same way. How do we go by and create the BOP safety culture? And so we'll talk about that. And then the next one is enforcing safety. It is important in the sense that, we can write all the rules and all the regulations in the world, and we can tell the power plants, here is the book, it has all the rules and regulations, go do it. And we know what's going to happen. It is not going to happen. So there are agencies and the organization, their sole purpose in their life is to regulate the nuclear power plants and ensure to make sure that they are following the rules and the regulation that has been already laid out in front of them. So, and we'll talk about this slide little, but like NRC is the main enforcement agency for the nuclear industry, especially for safety. So we'll talk about that. Then developing BOP safety culture. So I keep a separate slide for that because Kamal helped me out in kind of formulate these how do we make this thing happen? Because it's easy to say what the nuclear safety and then just go over to the other subject. But the nuclear safety and especially the non-nuclear safety part is rather tough to find how exactly, because there is no set numbers or the criteria that you're going to follow. So these kind of fluid, and so they are developing safety culture for BOP. I have a separate slide because that's a little tough to come up with. So I'll talk about that a little bit. Poor safety culture and consequences. that's an interesting slide. What happens when the safety culture is not appropriately followed or internalized, and what could happen? The slides that I put there is from my own personal experience. So there's a few pictures I put in there. We're going to identify the condition of the steam turbines after the accident, and we will go a little bit over the reason for the accident and what did we do after that. So this next two slides are analysis and conclusion and summary and takeaways. So that was slide 4. Let's go on slide 5. Okay. NAAA safety approach. Okay, my dear friend Dr. Pradeep Saha, a few weeks ago, he gave a presentation where where he talked about basically the analytical approach based NAAA design that emphasizes on the fuel integrity, because that's the bottom line. To maintain the fuel integrity, you cannot have a failed fuel, or you cannot challenge, or you cannot overstress the fuel. That is the premise. So everything is geared towards that. And the other thing that is been geared toward that is public. Is other thing that is we all follow is that the entire safety culture for NAAS is to protect the public from any radiation exposure. And from NRC's point of view, that's the only thing they care. They don't care that the power company lost millions of dollars or anything. You know, they are totally oblivious to that. Only thing they care is public safety. So what Pradeep emphasized is that if we follow all the NAAS criteria and what the analysis is set, and if we follow those things and keep those things intact by creating safe procedures, internalized safety, then everything will be safe. So from the analytical approach, we take and change them and kind of proceduralize and say, this is how you're going to follow, so that the numbers that Dr. Shah and his party created, they will be maintained. So that's important. So the next bit is, in AAA side, safety is controlled by Code of Federal Regulation, or CFR. CFR is a law of nuclear industry. It's a safety. Its law means that in a willful violation of 10 CFR is punishable. So, there are incidents in industry. There are 2 CEOs had to go to jail because there are willful violation. So we follow the rules and the requirements of 10 CFR 50. 10 CFR 50 basically, it is not only the safety act, but 10 CFR 50 is a domestic licensing and the production and utilization on facilities. It lays down all the rules and the requirements associated with nuclear plants. So out of 10 CFR 50, we are really interested for our presentation and for nuclear safety is 10 CFR 50.59. 5059 is a very common word in the nuclear world. And we'll go over in details later on. Nuclear Regulatory Commission. I think anyone associated with the nuclear industry, we all know who NRC is. but NRC is the ultimate authority of for the nuclear power industry. Basically, they have the power to take the QA and shut your plant down if there is any violation of anything. Like I worked in Illinois Power. At one point, we were shut down for 3 years because there were violations of, there was a fraudulent paperwork and violation of existing procedures, which we didn't tell NRC. There's a lot of, it's almost near criminal activities. So we lost our operating license for 3 years with a big loss. And the company did not exist when they restarted after 3 years because their financial condition was so poor, the company was bought out by Philadelphia Electric. So it is a serious business. NRC can break your company. So we always follow what NRC says. And then the last bullet is an entry plus safety approach is protection of public, financial impact ignored. Basically, I told that we have to make sure, or NRC is telling us, then as a plant operator, you have to make sure that number one, there is no nuclear accident. You protect your plant from any accident. But if we have one, you have to make sure that the public is protected. And there are things that we do to make sure that public is protected. And we'll talk a little bit about that. Slide 6. Okay, here is that beautiful picture I was talking about. This is, I took it from Google. I think Kamal told me just go look for Google because I wanted to put one that I have, but it's so big and so clumsy, I just couldn't. So this is the pressurized water reactor. As we can see, we get the reactor vessel in the middle on the left-hand side, and then we get the 2 steam generators. And then we see the 2 steam pipes coming out of the steam generator. Actually, there are 2 plus 2, 4. The typical setup is 4 steam pipes coming out. So they're coming out, then you got 2 isolation valves. You can see main steam isolation valves. Those are the 2 isolation valves I'm talking about. So up to the second isolation valve, including the containment vessel, steam generator, pressurizer, and everything else, moisture separator, they are safety system. They are part of NT+. There's safety system. And everybody's, including NRCs, their interest is up to that point. And then downstream of that, that goes to the main steam, flows into the LP turbine, then from the turbine to the condenser, then feed water heaters, all that generator, exciter, all that jazz. That's BOP, or the balance of plant. They are typically, I say typically means that there could be 1 or 2 exceptions, but they are non-safety and built accordingly. And I'll give a little bit of idea what is the building code for NSSS and what is the building code for non-safety. That gives you a little bit of idea. So that's slide 6. Okay, let's go to slide 7, see what happens. Okay. Nuclear safety culture process. This is a process flowchart that really tells the whole story about the nuclear culture. I picked it up from Google because I could not put the one that we use because of NDA issues. But this is almost like 95 to 98% correct. So these talk about how a safety culture process works on any nuclear plant to ensure that there is no accident and the people are safe Along with that, there is another safety that we consider, we means owners consider, that's the financial safety. Like I said, when our plant got shut down, obviously the financial safety was severely threatened. And then the company went bankrupt. And they were sold out at $20 million to Philadelphia Electric. It took $6 billion to build that plant, and it was sold at $20 million with all the other debts. So financial threat is also a safety hazard. So that's what financial health we always talk about. But for NRC, it doesn't matter. They don't talk about that. The only thing they talk about is the people's safety. So in this safety culture process, we have the lowest long bar is the corrective action program, or CAP. That terminology, corrective action program, is pretty universal. Almost all the plans uses the same terminology. What it is if there is an incident, it could be a big incident or it could be a minor incident that a pump fell apart, which is not, the pump was operating fine yesterday, today it just completely fell apart, disintegrated. So that is an abnormal failure, and that will be captured in the corrective action program. And the corrective action program basically will walk you through the root cause analysis and all those things, and then it will nail down the root cause. And then, of course, then you have to create the corrective action so that it doesn't happen in the future. So this corrective action program, if you just go look at the input, who are the various organizations that input? They're like, I'll just give a few examples. NRC has an input in that process. Then operating experience, OE, that what we call, which means that we go back to the database and see what are the other plants had the similar incidents. And then we capture those and put a corrective action program. That's their operating experience. QAQC, self-assessment, or QAQC staff, they have the input. So all these people, they make the input and create the process or the program. And so incident is captured in a database called the condition report. That the condition report that identifies what happened, and that is the form that every day you just fill it up by various groups to give their input to come up with a cause analysis and the corrective action. So that's one thing that that we follow to create the safety culture. Then the nuclear safety culture monitoring panel, every plant has that. And after their review, it goes to the site leadership team, and then then the site response is created, and then communication, and then external review, which is NRC, insurance companies, they're the external reviewer. So it goes through a pretty elaborate process, and that's all because a nuclear safety cannot be compromised, and a financial safety really need to be maintained rather than maintained. But it's all this elaborate process. It is a fairly good chance that if you follow this process, you may not compromise the nuclear safety, because the design, detail review, they are all built into it. Okay, so let's go to slide 8. Okay, it's a BOP safety approach. Okay, IIIS safety approach, we said because it deals directly with the public safety and the exposure. So it has all sorts of input. It has, let me just say that the NSSS is built to ASME Section 3 code, ASME Section 3 codes. And Section 3 code is pretty clear and it's very stringent how you build the NSSS. Along with it, there are other codes and the standards that go into the NSSS safety system they design. The BOP at the same time goes to B31.1 code. I think I have a slide later on, which is not as stringent as NSSS. So for BOP, NRC really stays in the background. They don't care how you do. I mean, they do care because it's a part of the plan, but they're not interested to know all your details, how you handle the BOP affairs. So the BOP affairs has come down with a few items, and the BOP is mostly self-imposed approach. BOP safety approach is self-imposed. Every utility or power plant owner, they create this for themselves to use it. They create their own monitoring group and the people to follow through. And because they want to have a favorable commercial outcome. In other words, they want this plant to run from outage to outage, 24 months without tripping. That means the enormous cash flow they enjoy, and they want it that way. So they already took care of NSSS part. It's already safe. Then they go to BOP and says, and we need to take the commercial part. So make sure every component and the BOP, they are designed, operated, and maintained in a way that I do not lose plants. And I remember when I first joined Illinois Power, first year, we have 5 outages. Because every 3 months or 2 months, we used to trip. And that was acceptable at that time. People didn't care too much. But that has changed. Now you run 24 months from one outage to the other outage when you change the fuels without coming offline, which is big deal. And all the owners want to maintain it that way. So that's one aspect. Then the other aspect is the equipment integrity. We saw, and as I saw, failure of turbine and what it caused, what it did to the utility, and we'll go over with that a little bit. So equipment integrity is also very much in focus for the owner. Then we get safety significance. Even though BOP is a non-safety, it could impact safety. For example, on a boiling water reactor, on a boiling water on the steam goes into the steam turbine. Those steam is radioactive. Even though they are inside a non-safety building and the non-safety system, but if we have a mainstream line rupture near, say, turbine or anywhere in the turbine building, you're going to be spewing radioactive steam all over the building. So it does have a safety significance, even though those are rare occurrence. Mostly it doesn't happen, but it could happen. I remember once the design on the steam jet air ejector condenser evacuation. When I took over the design, I realized the guy who did it before me, who took the pipe that takes all the exhaust from the main condenser, which has the nitrogen 16 was the isotope, is very radioactive. a passing through turbine building clean area where normal people just walk in and out, but that's a bad area for that pipe to run. So finally we fixed it. We put a jacket and we filled out the jacket with the lead shot. So it had about almost like a 3-inch thick lead shielding all around it. It was expensive, but yeah, you really have to see to make sure that it does not create a safety significance issue. So that's owners do take interest on those. And then impact on enterprise system structures and components. That also can happen. For example, during outage, you have a significant load drop on a turbine building, say, truck bed. You dropped a turbine casing, and it will set the seismic monitor right away. And once the seismic monitor is set, it'll go to trip the plant. If the plant is operating on full power, base power, it's going to scram. And I will talk about the scram a little later, why it's bad. So owner not only take the safety approach from the enterprise, but they also look at the other side and make the BOP as good as possible for all those points. Okay, slide 9, please. Okay, enforcing safety. So this is like, police enforcing all those people, doing the crimes. I mean, it's almost like that. I mean, you cannot trust the utilities that on the enterprise side, that they are going to implement everything as needed. So finally, the NRC is basically the number one enforcing authority. And what they do is, on the first bullet, what they do is they issue bulletins. And the bulletins, for example, when we had Fukushima, NRC issued bulletin in this country and gave every utility to implement that Fukushima-related modification within certain period of time. And you shall implement those in that time frame unless there is a good reason. If you don't, then you have to face the consequence. So that's one of the enforcing activity. The other enforcing agency is INPO, Institute of Nuclear Power Operations. INPO was created after 3 Mile Island accident because up until that point, 79, there is no central agency anywhere in the country who really looking at every aspects of the operation and maintenance and make sure that it is done correctly. And TMI accident kind of open up that view. So INPO, Institute of Nuclear Power Operations, was created, and it was small back then, but INPO right now it's huge. It's based in Atlanta, and they don't have really a power to shut the plant down because they are not NRC, but they do have the power to rate your plant, how you're operating your plant, which is very important because NRC takes they're very powerful in terms of sending their message to everybody, including NRC and the financial agencies. Financial agencies, they not only look at what NRC talks about that plan, how they think, but these days they more or less look at how INPO is thinking about this plan. Because financial agencies, they're not engineers or they're nothing. They're a bunch of investment guys. But they will look at the INPO report and they will say, this plant is not worth investing in, and you're done. your stock will go to the floor. So INPO in that respect is very powerful. So they will make sure that things are properly implemented. Then other enforcing agency was insurance companies. If Sham is here, Sham is listening to this, and he knows all about this. How they manage their side of the business and make sure their interest is implemented properly. Then we have the state and the local agency, not only federal agency, but there are state and the local agencies that they also look at their side. Then we have ASME and OSHA. They don't really have the power, like I said, to shut you down, but their evaluation, their rating is very important. And the last item is the financial agencies. Now, we all think financial agencies, what do they know about enforcement of safety culture? Well, I tell you, they are probably the most powerful because they will call the shot and they will evaluate your company, and investment rating goes to the floor, and your financial future is basically doomed. So NSSS enforcement is very well coordinated. It's very defined and 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 uh, and and very detailed of how they're going to enforce. So because of that, even though NSSS failure could impact public, but because of this heavy duty enforcement and all these things, there is rarely any issue with NSSS since TMI. Since TMI, there had been no nuclear accident at least in USA. There is no even near accident in USA because this is what makes it so foolproof. So, but as opposed to NSSS on the BOP, these are missing. On BOP, we don't have this heavy duty enforcer. But what we do have, we do have NRC does not get involved. We do have INPO, they do. But there is another thing that the owners want to make sure the plant is built, operated, maintained in a way that it does not trip. Because tripping a plant from the full power is called scram, the full load scram. Basically, you drop the control rods, and when you do that, it stresses out the fuels. So even though your BOP, but you still have the power and the capability to stress out the fuel through scram. That's why the scram has been added in INPO evaluation as a criteria. How many scrams you had? If you had X number of scrams, then they will tell you that your operation is substandard. You had so many scrams. So the owners and the operators, they want to make sure that they do not take a scram, which is if the plant is operating in excess of capacity of the bypass valve, which is typical plant is about 25%. If you have a 15 million, 14 million pounds per hour stream flow, so 1/4 of that will be the bypass valve bypass valve capacity. As long as you're running below the bypass valve capacity and you treat the plant, it is not going to scram because it's going to go to the steam is going to go to the condenser as a bypass. But if it's higher than that, it's going to scram. Full load scram is the worst. So owner does not want any scram, period. So they are saying create a design and operation basis that will eliminate scram, even though that has nothing to do with NSSS safety. but they will spend the money and the resource to make sure that the technical rigors that is needed to create this is being used. So that's what it is. So I said NRC might get involved due to Scrum. If it is Scrum, yeah, NRC will certainly will get involved. The INPO will have a significant presence and will rate the performance. Like INPO audits, I just talked about that. And these are just the rating the best rated plan to the first quartile, and the best rated plans, their financial the situation is in very good shape because their cost of borrowing money and everything is very low compared to other plans with a bad input rating. So safety culture in BOP is primarily self-enforced by the power companies to eliminate scam. Scam is probably the most important thing on the BOP safety culture. And then the financial things also part of it. Slide 10, please. Developing BOP safety culture. Okay. Based on the understanding that the safety culture must be embedded in design, operation, and maintenance. That's a very general statement. What it means is that the technical requirements, the technical analysis, and the engineering involvement in any product that is needed to modify the plant or whatever we are doing, the rigors is there. It got to be analyzed to the nth degree. I mean, we do that. We take as much time as you need and as much money as we need to make sure that it's done correctly. So lack of technical rigor during design development results in equipment failure and safety challenges, which we talked about. Then I'll show you some of the slides of a failure of turbine. This is where I used to work. Unfortunately, I cannot name the plant because of the NDA issues, but this plant is somewhere in the Midwest. It's a large plant, is a PWR, it's a large plant, it's a 1200 megawatts each unit. So it's a 24 to 2500 megawatt flowing out of the facility. They changed the turbine in 2006 and started the plant. And go to the next slide, and then yeah, there you go. Poor safety culture and consequences. So here's the floor where we're showing the turbine at the far end. Then you get the generator next. Then you get the exciter closest to us. So that is the setup, and the main streamline is going out. We can see those two main streamlines from each of the turbine. So that was the clean plant. And then we're showing the condition of the turbine after it failed. As you can see, there are 4 blades missing. They're just gone. And a host of blades, they're just gone, and they're broken. So this last stage, L0, is a catastrophic failure. The only thing that's saved is when the blades get dislodged from the root, it did not become missile. So it did not penetrate the outer, if you look at the turbine, the outer, which is exhaust hood, it did not penetrate the exhaust hood, but the inner casing was severely damaged. So that's what happened. So it said in 2008, this is a catastrophic failure, and the total of 4 L0 blades failed. inner casing and the condenser neck region of the LPV turbine were all but dead, destroyed. I mean, if you look at this, how inner casing and the condenser neck area was worked, you will see the power of 1200 megawatt blades when they are hitting those walls, how much damage they can do. It's amazing. The high vibration caused extensive damage to the normal areas. The shaft has to be redone. And of course, the plant was scrammed. We notified NRC got involved, but there was no personal injury or there was no fuel damage other than scram related fuel stress. So go to next slide, please. 12. Okay. So before I go on this one, so what happened is after that, then we decided, the management decided that we need to bring the power up. We cannot just sit there and so let's start the blades out and put pressure plates. That's the picture I'm showing right here. Is the pressure plates is installed because on the last stage blades, when the steam expands, it has a pressure drop. And what the condenser sees is the reduced pressure coming out of the last stage blades. So you have to recreate that. Otherwise, the condenser is going to be damaged if you put the light steam. So you design this thing with the holes, carefully designed by the turbine manufacturer, so that when the steam comes through those holes, they go to the pressure drop. So the steam at the exhaust will be exactly the same thermodynamic condition as the exhaust to the last stage blades. So, but you lose power because the last stage blade produces the maximum amount of power from LP. So so we lost about 200 megawatts, and it took us about 2 years to fix all this thing, and then lost 200 megawatts. Then we started the plant up, and at the same time we are planning to replace this turbine with a brand new turbine. Okay, let's go to item 13. Okay. Analysis and conclusion. Obviously, the extensive root cause analysis was performed. I was talking to Kamal. There are 3 books. Each book is about almost like 3 to 4 inches of thick. There are 3 books full of root cause analysis. It is done by a company called PII, Performance Improvement International, did a great job. And so basically, after the root cause analysis, the conclusion was that it was high cycle fatigue failure of the blades. And there was not enough margin on the blades, on the stress margin on the blade left. So when an incident, the blade just simply gave up. I have some of the picture will show you the beach marking of the blades, which indicate that high cycle fatigue. So the reason that this suffered that significant damage and the L0 blades failed, it was part of the reason was a phenomena called torsional vibration. And what torsional vibration is basically a phenomena which is created when the generator from main lead and downstream up to the T&D line, if there is a fault, that fault will create a forcing function whose frequency is 120 hertz. So we are very careful about what we do and how do we mitigate the effect of that failure. or affected the fault. Fault is going to happen. No one can stop. Not only fault, but even when you synchronize the generator out of sync, even if you out of sync by 4 degrees, it will create a negative sequence current, I2, and that is going to cause a torsional frequency. So there's a lot of things that play, and these are the well defined in the specification, and we gave them this specification to the owner. And the company that they did the spec, they really didn't have a whole lot of knowledge on this issue. So they missed out on those. The company, the manufacturer, they told, yes, we have analyzed, this rotor is fine. This rotor has 6 hertz separation from 120 hertz. So this rotor is not going to be having a frequency of the 114 hertz to 126 hertz. So we are safe. But either they lied or they made a mistake. The few days before the startup, I already left the company. I was attending a wedding in Columbus. I got a call from this company. They said, can you join a conference call? We are having some problems. So we joined. Basically what they said is the manufacturer reanalyzed the rotor and they found out they have one frequency, dead nut on 120 hertz, which means that the turbine won't be able to start. So they made a proposal that we're going to add some D2 in the blades. We're going to add some small weights on each of the blades, which was the wrong approach. But anyway, so that's what they did and started in 2006. And in 2008, they had this turbine failed because they have hosed up this turbine so bad that when they have a torsional event, the blades just simply flew. They didn't stay there. And they, like the spin pit test, I added here. Spin pit test is an extremely important test. And I found out later on, they had a golden opportunity to really identify if there is any problem to the spin pit test. But they never went to the spin pit test. So there was a lot of reason why it failed. Let's go to the next slide. Okay. Then I just talked about the frequency separation of plus minus 6 hertz from 120 hertz was required by the specification. In the compliance, however, there is manufacturer probably lied. And then they raised those the weights at the tip of the plates, which is completely against the normal rule that you should not braise or you should not weld on the turbine blades because 12 chrome is not weldable, and everybody knew it. But owner accepted that because owner wanted to start the plant up so badly because this is their third new turbine that they are from 1975 up to 2006. They have replaced within this one. They have replaced 3 turbines. They don't have a good track record. That's why they said, well, no, put it in and let's get up. So that's why it was done. And the other thing is, torsional thing is on the nuclear turbines are really massive. These last stage blades, the subsequent turbine, brand new turbine, I wrote the spec on that one. They're 56-inch long. So you do 56 times 2, and then the diameter of the shaft, and you can imagine how big the last stage area is huge. So then this manufacturer, they made these blades as a freestanding. In other words, a 56-inch blade is standing freely on its own. And there is so much of a complex of hydraulics, hydraulics interaction and the vibration that nobody dares except this manufacturer. The only reason they did it because it gives you the highest megawatt because you don't lose much power. But most of the other turbine vendor, either they take 6 or 7 blades, put a tie wire and weld every one of them, or put snubber between 2 blades, and so that they don't individually they don't shake. But that was one problem that they had. But anyway, so that was owner's call. Owners got what they deserved. So we can say, okay, let's go to the 15. Okay, this is the analysis committee. This is the last slide, I guess. If you look at this picture, on the bottom areas on the blades, you see those beach marks, like on a sandy beach on beach mark. And that's typical telltale of high cycle fatigue failure. And this is not I gave just one picture, but there is a bunch of blades, almost all the blades had beach marks. And every single blade where they added the weight had cracks, even though it didn't fly off from even though the tip didn't crack off the blades, but they were all cracked. Even if they could save from the torsional, it would have failed on the tip. So this is the high cycle fatigue phenomena, and that's what happened. We believe that's the primary reason that it failed. And I said that the freestanding blade 50 in most lot, I mean, either tie wire braced or snubbered. Okay, next 16. Summary and takeaways. Okay. As I mentioned, this presentation in large part based on my personal experience since TMI accident. Over the last 50 years, almost all NSSS or BOP accidents have a common cause of failure: insufficient knowledge and lack of willingness to apply rigors. The relaxed approach resulted in compromise in operation, design, maintenance, and other critical functionalities and created an unsafe environment. This shift remains largely unknown to the user until a significant failure occurs. Owner does not know that their folks or they have far away from following the safety culture until a catastrophic failure happens, like happened where I worked. Therefore, safety is a culture that must be internalized and embedded in the daily activities. And there had been, from my view, there had been significant change on the owner's approach to the daily activities and accountability. So now they are pretty decent shape in operation. And then we bought the new steam turbines and we specified just about everything in great details. We had a NSSS, say not safety plan, NSSS quality plan. That quality plan, every aspect of NSSS design and manufacturing, how we're going to follow through every one of them. So those things are already in place, and I think they follow pretty well in terms of managing the safety. So basically, the safety for NSSS and BOP means analyze each action, engineering, manufacturing, testing, installation, operation to name a few, must be rigorously analyzed to the nth degree to look for errors and fixing. Tools process quality plan and oversight plan and rigorously enforce. I think that's probably it. So let's go to next slide 17. Thank you. So that ends my presentation. I think 8:25. Sorry. So I can take few questions. I don't know if I can give all the answers.
Thank you, Shubhendu.
Floor is open.
We really appreciate your presentation. It was very interesting. And since I'm a moderator, I'm not going to talk anything about it. But what I'm going to do is that I will request first, with permission of the floor, I'll request Pradeep, Dr. Pradeep Shah, to talk about it. After that, I will ask Uchudda to make your comment because he's concerned where you started the whole discussion. Okay, after that, I will open the floor. Pradeep,
Kamala.
you have anything to say? Because I think there are a lot of questions, concern. I'm sure a lot of discussion will happen. So I'm
Kamala.
trying to sort of channel. Okay, start with Pradeep and then Uchudda.
Kamala, may I just request something since I have to jump in another call in 2 minutes?
Okay, I will allow you to break the line. Go ahead.
Okay. Well, first of all, thank you very much, Shubhendu. My name is Biman. I'm 81 Metallurgy. Just
Yeah,
since
I
you
see your
mentioned
name
about
all the time.
and there are a lot of students present here, I'd just like you to comment on the culture on safety, especially, we all talk about this not in a cliche term, that culture is strategy as breakfast. And a lot of the culture thing is influenced by the political environment. Since you mentioned about the 3 Mile Island, the students, I suggest you, if you have not watched the 4-part documentary on 3 Mile Island called Meltdown, please watch it and see that how the culture thing prevails and how the political interference can eat up all your engineering judgment. So since you will be you are budding engineers, you will be practicing professionals, I would just say that, well, this is one constraint you need to keep in your mind. And although I won't be here for any longer, but if Shubhenduda or other expert professionals, including Uchudda, have any comment, I'd listen to the recording at a later time. Thank you very much.
Okay, I have my phone number there in case if there's any follow-up question, you can always call me or send me something. I can do that. Okay, thank you.
Shubhendu, Biman is a scholar in the areas of materials, joining, and alloy system. He's very good at it. You can talk to him later. Okay, thank you, Biman. Okay, Pradeep, you want to say something before I
Yeah.
open the?
Can you hear me?
Yes, you can.
Oh, okay. It was a very nice presentation, Shubhendu, and we learned a lot because in my profession for 45 years or so, I was mostly in the NSSS side, which you mentioned in the beginning. And of course, this scram means the total shutdown of reactors in the plant. No owner wants it because that is the loss of electricity generation and their pocketbook. Now, I have a question, Shubhendu, or a clarification.
Sure.
I think I heard you saying that nowadays the plant runs when they change the fuel. How can it be possible? You said without outage, they change the fuel every 2 years. I mean,
Right.
1/3 of the
Right.
fuel, not the entire fuel. Can you explain that
Well,
a little bit?
Some plants have 18-month refueling outage. Some plants
18
have
months or
24
24
months
months?
refueling outage.
Yeah.
But
Correct.
these days, the 94% capacity factor, the big contributing elements to that is the plant's ability to continue to run with an outage to outage. They don't come down. Most plants, I would say good 60% of the plants, they stay online in between outages. They just don't come down. Uh, while I work in excellent plants, um, excellent plants don't come down. they
No,
just
but
stay
do
online.
excuse me, do they produce power when they are changing the fuel or taking 1/3 fuel out and putting 1/3 new fuel?
Yes, yes,
They don't. That's
yes.
interesting. I didn't know that.
And basically they also take a very short outage.
Yeah, short
After,
outage, I know.
right,
Yeah.
after continued operation for say 18 months, they
Yeah.
only take maybe 24, 25 days outage. They
Yeah.
do
Even they
all
try for
major
21
maintenance
days
work.
or something. Yeah.
Yeah, yeah. That's
Okay.
the trend right now.
Correct. Because they want to reduce the weightage time as small as possible.
Yes.
That I understand. But how can they produce power and send electricity to grid when the top of the reactor vessel is open? I don't know.
No. Except that outage, obviously, when it's outage to outage, when initiation of the outage to that when the outage for 25 days, plant is making no power. So that's done.
Okay.
But once the plant starts from the outage,
Yeah.
and for the next outage, 18 months, it doesn't
Right.
come down. It
Okay.
runs.
All right. I think I misunderstood.
Yeah.
Okay, fine. Thank you. Thank you. And
Okay.
anyway, it was a great presentation. Thank you very much. So when are you coming
Thank
back
you.
to Chicago?
Pradeep, we'll talk about that later.
We're feeling
Ajita,
sad. We are
Aj-
feeling sad and
Ajita,
excited. We will be starting November 12, right? November 12.
Okay, let Ochyuta
With
shoot
order,
his.
yeah. Okay, Ajita.
order,
Is-
order from
Uchida,
my
bolo.
dear Shubhendu, I am graduate from this college in 1961 in mechanical engineering. So, but everybody present here knows my views about atomic power plants. There should not be any atomic power plant in the world today. And the 440 atomic power plants that is existing, out of which 60% are operating, if you stop them, there will be poison all through. You don't know where to throw the poison. The poison, they are creating poisons and you don't know where to store the poison. It's a perennial problem. You can put this poison from here to here, these pen fuels, from here to there. This is my view about it. And so I am, you see, Shubhendu was so clear. You know, some, what a brainy engineer who has bridged at the end of a tip, bridged an additional mass. What kind of brilliant engineering, my God! And the foolishness of this, I am astounded. Now, this kind of foolishness will go on occurring. And since I have got a motor car, so many of people have, they have got an accident. So what do? It breaks down, but it doesn't kill many people. It may kill one. But this Fukushima, Chernobyl, 3 Mile Island, there 5 volume of books has been printed in the New York Library on Chernobyl. Since Chernobyl in Russia, all the Western people were very interested to show it is their fault, their fault, their fault. So there are 5 volumes. They estimated that considering the death till now, 10 million people will die from Chernobyl. So now let us think about Fukushima. What has happened? The elephant foot of 4 has gone down the sea. We don't know even where they are, the chorus. Where they are, we don't know. So they are polluting the whole ocean. So this is my view that to start with, I'm sorry, this is my view, everybody knows it. To start with, there should not be any atomic power plants in this world. But now that we have done it, we don't know what to do with it. Even how to stop it, that also we do not know. That is my very clear opinion about this. My dear Shubhendu, you gave a very beautiful lecture, very clear functioning and all these things. But this is the overall view. Thank you. I am sorry.
I'm not trying to refute, but just one quick response to it. What the point that you brought out because of the unsafe, and there are a lot of work is still going on. The modular reactor, they will safer and all these things. But the bottom line is, যখন Henry Ford গাড়ি বার করেছিল তখন there was a same feeling because we cannot drive this thing. We're going to kill people. We're going to So anything new that comes out, it happens. If you just think about this, since 1969 or 70 to up until now, if you look at the nuclear power's safety records, it's enviable. It is right now.
I will not dispute that. But unfortunate thing is, in last 40 years, there has not been a single atomic power plant built in US.
No, shouldn't fuel.
Okay,
Pradeep
I
talked
think,
about.
But I should
I
stop
think
talking.
Achyuta,
Bye.
let's do it this way. Let's make it this way. Let's agree to disagree because this is long discussion. Okay, we are
Yeah.
talking about
Yeah.
we are
Yeah.
talking about a very important subject, and I'm sure a lot of people have a lot of questions. Let's
Right.
open the floor
Exactly.
to those things rather than a definitive idea or vision or conclusion by one single person, even if
Thank
he's
you.
extremely
Thank
respected.
you, Komal.
So
Thank you.
floor is open to everybody else. Please start asking question to Shubhendu. Thank you, Jidda. Okay, anybody else? Questions? Anybody?
This is Sham.
Okay, go ahead, Sham.
Yeah, Shubhendu, that's an excellent presentation. What I was
Thank you.
wondering was that we had a plant in South Africa. The name of the company was ESCOM, and they lost a couple of those L0, L1 blades, and those blades jammed in the shaft, broke the LP shaft into two, jacked up the turbine rotor from its base,
Yeah. Yeah.
broke all
Yeah.
the lube oil power lines. The only comment I'm trying
Right.
to make is
Right.
I think
Right.
with that failure, this particular plant got away very lightly. You know,
Right.
they had to change even HP turbine because the rotor bent and the shaft was broken and lying somewhere in the plant
Mhm.
floor. So those L0, L1 blades,
There is
all the
the
analysis
Fermi
is
plant.
plus
The Fermi
every
plant in
outage.
Michigan.
Say that
The
again?
Fermi plant in Michigan, they had a GEC turbine, English
Yeah.
Electric, GEC turbine. Their L0 blade came loose and their projectile ended up in the parking lot. So, it has, just imagine they're like 1,000 megawatt of power. Then
Yes.
at that power level, suddenly two blades just
Yeah.
come loose. With
Yeah.
that power, they can penetrate the inner casing and exhaust hoods.
I
I
have
mean,
seen them penetrate the exhaust tube and gone through the roof of the plant, building holes in
yes,
the roof.
yes,
And
it
the
does.
only one of the things that we insisted on is every outage you must do a complete NDE of
Right.
those blades to make sure there is no inherent cracks.
Yeah.
And that we kind of followed very closely.
Yeah.
And that's all I had to say. I thought that turbine got away very lightly. Okay.
No, this plant, they got lucky. We all agreed. They got
Yeah.
real lucky. Their damage was able to fix it in 2 years. But just one concluding statement on your inquiry about this blade flying. The nuclear plant has a two orientation. It's called favorable or unfavorable. Favorable orientation is center line of the reactor, center line of the turbine is along the same line. And the thought is if the turbine blades comes loose, it is not going to hit the reactor building roof. So the analysis, safety analysis, or the USAR, and we talk about unified safety analysis report. Safety analysis for unsafe plants, like if the reactor building and the turbine building, they're side by side, and if the turbine blades come loose, it has the potential to hit the reactor building, and that the reactor building has been analyzed with that. So, turbine blade becoming missile and hitting the reactor building, it's not a hypothetical assumption. It's the real stuff. because 1200 megawatt at power and the blade flies. Just imagine how much power that blade has. So anyway, that's all.
Yeah. Thank you.
Any other question from the students, faculty, anyone? The floor is open for everyone. Okay, there's no question. Then let me ask you a couple of quick comments rather. Frankly speaking, some of my friends may not like it, but let me tell you, I'm somewhat in the camp of Uchuddha. Let me tell you why. My concern is that, frankly speaking, after hearing you, Shubhendu, I'm a little bit more scared about nuclear safety than I was before. Partly it was my ignorance, probably. Now I think that, let me tell you where from I'm coming. My concern is that if we go back to slide number 6,
Okay, slide number 6.
and please don't get me wrong, I'm trying to play devil's advocate. Or that
Okay,
doesn't necessarily mean Uchuddha is devil,
the
but
picture.
I'm just somewhere along the line. Number 6.
Yeah.
Slide
What's the
number
question?
6. I'll show thee the slide, then I'll ask the question. Slide number 6, Bidut. 6.
That's it.
Yes. Okay. What happened?
This is a slide.
Okay. Maybe no, not this, not the slide. Next slide, please. Next. Okay. Yes, that's the one. Okay. Now what I'm looking for is that, let me tell you, I also worked very marginally for a couple of years on nuclear power plants component safety. Now but my strength is more in the medical device. So from that perspective, I'm looking at this structure, particular slide. Let me tell you what scared the hell out of me. You are talking about BOP safety approach, right? And you say BOP, I'm just reading a slide. BOP's philosophy of design, operation, and maintenance is shaped by the consideration on, that scared the hell out of me. Number one item is favorable commercial outcome. Given the complexity of a nuclear power plant, given the challenges of it, I think that should be the last one. Okay,
Well,
that is where I am.
yeah,
Okay, and look at the
I
order of business.
qualified my statement when I present in this slide. N-triplets part, which is the prime aspect of the nuclear safety, owner has already took care of it. They know that there is no issues on the N-triplets part. But if commercial part is become the last item, there is a lot of plants are simply going to fold because they drive they bring the culture, the commercial profitable culture in front of the people. And to be honest with you, the bonus and this and that, they're all tied up to the commercial outcome. But at the end of the day, they said you could achieve that without sacrificing safety. So design, operation, maintenance, the technical rigors have to be there so that you achieve the favorable outcome without sacrificing the safety. When we did this, the specification, even not similar, the Alstom, when they sold their turbine, we allocated huge amount of money for our inspector, and I was there in Switzerland, almost like 1 year, on and off, on and off. Generally, that amount of money is not spent during that stage unless the owner is committed to the safety. And they say this is a small investment. If everything goes well, we will get that money back very shortly. See, that thought process you cannot eliminate because that's the whole purpose. These are all private companies. These are not government. It's not PBA that keep on running on next budget will get $500 million. These are the private company. They have to make a penny to to stay afloat, and they do very well. Look at Exelon.
I fully appreciate it. I fully appreciate it because I work for private companies too. But I'm talking about optics. If you look at your list, it's commercial outcome. Third item is safety significance. I'm talking about the optics. Okay, that's all I'm asking for. Now, and obviously we don't have to take it anything personally. Now, another thing I'm talking about, when you talk about this oversight of BOP part, you rightly insisted that it is not controlled or covered or really surveillance directly by NRC. It is mostly self inspection.
Right.
Okay. Now I understand that part, but there are two concerns I've got really. Number one concern is that when a company says the financial survival is most important, and by the same token, he says, I will inspect myself. It is almost like judge and jury is the same. So that is scary. Okay. So I'm not finding fault with the system. All I'm trying to say is that what is the role of the safety process when something external review comes? Why is there anything we can think of to appease people like Ochudha and including myself, that where every company might be obligated by government mandate, including maybe NRC, that you must have a internal review process continually, not wait for the external review to come and find fault with you. There should be some daily log every day how the operation thing, and that must be publicly available.
Ochuta's question and concern is going to be for next 100 years. So it is not something that we can talk it over and make. But your case, for the question that you have, that's easy. When I say self-enforced, meaning that all the applicable procedure and the process and everything is created by the owner, and they set up the acceptance criteria, but it's not arbitrary. The acceptance criteria or pass-fail criteria, whatever it is they have to use, this is not arbitrary. This is either the extracted from the industry info or OE operating experience, or they get it from analysis. But that's how it's done. But it's not something that NRC is telling you go and do it. This is the numbers. You better meet, otherwise you are dead. It's not that. But it does. But if you look at the after I said the self-imposed, but if you look at the role of INPO on the BOP, INPO is an external agency. They have tremendous amount of power to make or break for that owner's financial health. If INPO says, and they come and audit every 6 or so months, and they ask everybody question, then they publish the INPO rating, and that goes to the investment house. And INPO is a bunch of engineers and the operators. They don't care whether what owner is thinking. They look at if the plant is good or bad. So even if it's a self-import, it doesn't mean the owner can do anything, because owner knows that if I can't, owner may have shortage of money and they may want to cut corners. Then INPO comes in and find that they have cut corners in the area that they should not have. They will rate the plan, probably say 3. It's a really bad rating. Their investment rating is even go down even further. And there will be even in the deeper hole of the financial. And owner knows that. Owner knows that even if I have financial problem, I got to maintain a top-notch plant, because I need to get input rating up and my investment grade up. And if you run a good plant, your operating cash flow goes up. So it's all points down to think you do the right thing, everything else is going to fall in place. You do the wrong thing, you start screwing things up, well, you're going to have problem. That's what really happens. But
Okay.
don't be scared, because just because the owner is going to do their thing.
May I,
Okay.
may I add something on this, Kamal?
Go ahead, Pradeep.
Okay.
Sure.
See, the one big difference is between USA and many other countries like India, China, Russia, even France to
Right.
some extent, is that nuclear power plant in America is still a private utilities property. They are the one who are running it. They are the one either making profit or taking loss, whatever. NRC is there, INPO is there, but they are not directly involved in the operation or financial health of the company. Whereas in other countries where in nuclear industry is more or less government owned, government run, like that, they don't care about that much about the profit and loss. So that is a big difference. So here in America, things are in checks and balances. So
Exactly.
whatever I know of last
Exactly.
almost 50 years in the nuclear industry here, yes, utilities may try to cut corner, but then there are other, particularly after 3 Mile Island accident, and as Shubhendu said, and as you all know, that there has not been any accident. Maybe there are incidents, and NRC used to have incident reports also. And it is open to public so that other utilities can also learn. So there has been, I think, this is my personal belief, has been a pretty good checks and balance in the nuclear industry in USA.
Yes.
Yeah, that's all I want to say. So nothing to worry. And I will not get into Chuda's argument.
Okay, I know.
So to assure Kamal,
Okay. Yes,
I
go
think
ahead.
I do not know whether those 4 bullets that Shubhendu put, that is really on a priority basis, or these are just 4 things that he put it. I do not know. Shubhendu can say that is really the financial health is the number one. It is of course a priority, obviously, to run a plant, run a company. But I'm sure they look into all the aspects of safety of BOP as well, because BOP can trigger something bad in the NSSS, and no owner wants that.
Okay, this final question I'm going to, because I think we're running late, for both Pradeep and Shubhendu. This is the data you gave us. Capacity factor in USA is 94%, and global average capacity is about 83%. My question to both of you that what is the technical reason for such a differentiation? It's a significant difference. We are talking almost like 15%. Is it because of technical knowledge, or it is because of what Pradeep says, checks and balance rather than compulsion by a government agency? What is the real reason of this significant difference in power output.
Let Shubhendu go.
There is not a single factor that causes. There are the mostly is by now all the nuclear plants components have been debugged, meaning that they have been operating for so many years. Hardly any plant just drops because some component fail. It does fail, but initial problems or the associated with the new plants is tripping offline. That part is gone. It doesn't. Now it's mainly operation maintenance and modification. How much you modify, what do you modify, that sort of stuff. But whether availability of the plant, in USA, and we did one audit with the Swiss people, and we realized this Swiss people were at that time, at least, they were more conservative than the US operation. If they see some perturbation, they will just drop. Where USA probably won't. So that has changed, but again, there is mostly this difference is because of the operation and modification related. Because the initial design that's frozen, that's done. The plant doesn't trip anymore because of the original lead and had some problems. That's over. So it's mainly operation and modification.
I think we are running way beyond our time limit. So I think Vidyut, you can take over. Thank you again, Shubhendu, for wonderful speech, and we really like it. And Achyuta, I need
Thank
a
you.
cup of tea from you for supporting you, right?
Whenever.
Good.
Yes, either
I,
in
I,
USA
work,
or in
I
India.
worked overtime for you. Thank you. Thank you,
Well,
Achyuta. Thank you, everybody. Thank you.
Thanks.
Vidyut, you can take over.
Thanks
Well,
to Shubhendu for excellent presentation.
Thank you.
on behalf of the department and on behalf of the Centenary Celebration Committee, let me thank our today's speaker, Mr. Shubhendu Dasgupta, for this nice presentation. Yes, we had a lot of queries. Unfortunately, we are running late a bit, so maybe we can't discuss anymore. Thank you, Shubhendu, for this nice presentation and nice enlightening lecture. I should also take this opportunity to thank our today's chair, Professor Shorkar, for nicely leading the session. It's a long session for Kamalda also. Might be getting late for his university engagements, I think. I'm not sure. Then yes, so with that, let's stop here. We close the session. If I could show, yes, this digital copy of the certificate, which we'll be going to send to Shubhendu through email. We'll also have a hard copy of the same thing along with a memento, which we will arrange to hand over somehow to Shubhendu sometime. So thank you very much. And thank you others, Pradipda,
Thanks. Appreciate it.
Achyuta, Pradipda, others.
And I will call
Thank you very much.
one of you, either Shudeep or Biman or somebody, because Kamal, you told me that I need to go to B College once to do something.
Please come and give a lecture.
I have only 2 more weeks, so I need to talk to these guys to set up the date so that I can go.
2 more weeks we are staying, right?
Shubhendu,
I'll
can I say
start it.
something? And also Vidyut and Shudip.
And in fact, yes.
Hello. Yeah, you know, I visit Chicago once a year, and Shubhendu's house is very close, not very close, but drivable distance from my son's place.
Okay.
So if you want to give that plaque
Yes,
or
I mean,
plate,
that
my
we could
plate
now
also
explore.
you can hand it over to Shubhendu.
Great, beautiful.
So Shubhendu, you
Thank
can
you.
pick up your plate and also my plate, and then I will take it
Okay.
from you,
Okay.
or when you come to
Yes.
Raleigh.
Few of the mementos we could, I mean,
Yeah,
that's how we could
I
see.
have no plan to visit Kolkata in the
Okay.
future.
Okay.
Okay,
We'll
I
try to
think
see.
we're
Right.
done, right? It's law fin, so we are done.
We are done.